All right, so we've completed the warm-up for lesson 6.1. So now we're going to get into what is radian measure. So radian measure, most of the time when we measure angles, we've used degrees. That's what you guys have seen. And on your calculator, we always talked about like getting yourself into degree mode. And that's because there's other modes, because there's other ways to measure angles. But for a mathematician, we would use radians. It would be our standard measure. In a lot of other cases, you'll see degrees, but in some areas of science and definitely in mathematics, you'll see radians being used. It's referred to as a pure number, and what that means is we don't usually state it with units. So I wouldn't, if you told me an angle last year in grade 11, I would expect you to tell me that the angle was 60 degrees and for you to include the degree symbol. But this year, when you state a radian answer, we typically do not state the units with that. So that would be my habit, is to not do that. Sometimes you'll see people writing RAD, short for radians, but that's less common. So a definition: the radian measure of an angle theta is the length A of the arc that subtends the angle. So I'm just going to go over to the picture here. So I've got a picture of angle theta. There it is. And I'm looking at the arc that subtends the angle. So it's the arc along the edge of the circle. And you could think about the angle as creating like a slice of pie. So A would be the piece of circumference along the edge or the slice of the pie. And of course, then we need to know the radius of the circle as well. And then altogether, sorry, the angle in radians is theta is equal to the arc length divided by the radius. So that's how we're going to calculate that. So you'll see some examples in your text. I don't have any examples in our lesson because I think it's pretty straightforward. They're going to give you the arc length, they're going to give you the radius, and you're going to plug that in here, and you're just going to calculate the angle in radians. Or sometimes they might give you the angle in radians and the radius, and then you'll just rearrange this formula to find the arc length. So moving along, what does 1 radian look like? Well, if I think about that, if I think about what happens when the radius is equal to the length of the arc length. So here now I've drawn the arc length to be the same length as the radius. So if I thought about straightening out that arc, it would turn into the same length as this here. Well, then my angle, I know, is the arc length over the radius. But now the arc length is just the radius. And if I take any number and divide it by itself, that's equal to 1. So here, what does 1 radian look like? It looks like when I take a slice of pie and the arc length is the same as the radius, then this angle in here would be 1 radian. So it's kind of a pure definition, right? Because it would be the same for every circle, just the arc length being the same as the radius. All right, so how many radians are there in a full circle? So I'm thinking about, here's my radius, and I'm thinking about rotating all the way around the circle. Oops, a daisy. So I'm thinking about rotating all the way around. There's my angle theta. Well, then I need to think about, well, what's the arc length for that slice of the pie? Well, that arc length is going to start here and go all the way around the edge of this circle. And so my arc length is actually the circumference of the circle. So in mathematics, we know that to find the circumference of the circle, we do 2 pi times the radius. Well, then theta, remember, is the arc length over the radius. And so I can sub in what I know. I got my arc length is now 2 pi r, the radius of the circle, divided by the radius will give me the radians. And here I can take the r's, because I've got all multiplication in the numerator. I can cancel those r's away, and I'm just left with 2 pi. So in an entire circle, we say that there are 2 pi radians. So we know that in a whole circle, in degrees, there are 360, and in radians, there are 2 pi. So to do conversions between degrees and radians, we know that 360 degrees is the same as 2 pi radians. So I can think about just the top half of the circle. So when I think about just the top half of the circle, we know that the angle here would be 180 degrees. But if I know the whole circle has 2 times pi radians, then half the circle will just be pi radians. So we're going to use this conversion factor more often because it's in lower terms. So I'm going to show you 4 different methods for converting between degrees and radians. Some of them you can only use in one direction, going from, for instance, in our first method, degrees to radians, but not going backwards. So if I know that 180 degrees is the same as pi, then when I do pi divided by 180, that's just equal to 1, right? Because I'm actually just taking pi radians dividing by 180. It's the same thing divided by itself. That's always equal to 1. And since I can always multiply by 1 and it doesn't change anything, I can just take the degrees that they give me in the question. So here they're giving me 30 degrees, and I can multiply it by 1. But in this case, instead of using 1, I'm going to use the equivalent pi over 180. And then I can simplify this. So I've got now 30 pi over 180. And then I'm going to reduce this to lowest terms. So I can think about, well, what can I divide both top and bottom by? Well, I can divide by 30 on the top, and I can divide by 30 on the bottom. And so then I'm going to end up with just 1 pi on the top and 6 on the bottom. So I would read this as pi by 6 radians. Method 2, if I want to go from radians to degrees, using the same method, I'm just taking that conversion of 180 equals pi, and now I'm just writing it in the opposite direction. So again, I still have the same thing over the same thing, 180 over pi. Those are the equivalent measurements. Then I can say that that's also equal to 1. And I could also always multiply by 1. This time I've got it in the right direction, that again, the radians are going to cancel. In the last one I had degrees was given to me, and then I was dividing by degrees, so the degrees cancel out and I'm just left with radians. This time I've got radians in the denominator, pi, so I want to be starting with a radians example. So I've got 2.25. And again, they gave me this with no units, right? It says convert 2.25. 2.25 what? It's radians if it's not written. So we're converting that to degrees. So I've got 2.25, and I'm going to multiply by my conversion factor, 180 over pi. And here the radians are going to cancel out, and I'm just going to be left with this degrees on the top. For this example, I'm going to have to be using a calculator because I don't, because I've got a pi involved, and because the question started with a decimal, so that's another good hint. Usually on the test or in the future, or like in your textbook, you'll see them ask you to round to the nearest tenth or the nearest hundredth, something like that. I'm going to round to the nearest tenth, so that's 1 decimal place. So I'm just typing this into my calculator as 2.25 times 180 divided, and I'm using the pi button on my calculator. And I come out with about 128.9. And again, it's degrees because the radians canceled out. All right, so method 3, we're going to use this to convert radians to degrees if the given measurement has a pi in it. So a lot of times when we're given a radian measure, it is given to us with a pi in it. And we're going to keep working with this so you'll get more familiar as we go along. For this method, if there's a pi in it, I'm just going to sub in that pi is the same as 180 degrees to do my conversion. So notice in my last example, there was no pi, 2.25. That's kind of unusual. This time I'm given a radian measure, 5 pi by 3 is how I would read that. And so I'm going to convert it to degrees by, again, just replacing the pi with the 180. So I'm going to take 5 pi by 3. I'm going to say that's the same as 5 times 180, all divided by 3. And then again, I'm just typing this into my calculator or doing some mental math and figuring out that this is 300 degrees. And that's an exact answer. Okay, so method 4. Method 4 is always going to work. It's a few more steps, but it's going to work whether I'm starting with degrees and moving to radians or starting with radians and moving to degrees. So for this one, I'm going to use this proportion where I've got my degrees number from the question or the radians number from the question, and it's always going to be equivalent if I reduce them to lowest terms to 180 over pi, because I know that that's always the relationship between an equivalent degree and radian relationship. So once I sub into that proportion, I'll cross multiply and solve. So we'll do a couple of examples using this method since it always works. I'm not going to write out the full word degrees and radians every time. I'll probably just write D over R is the same as 180. It should match, right? If degrees is on top, then you need to put the 180 on top. And then in radians, that's pi. And then I can sub in what I know. So I know that the degrees measurement is 315. So I'm going to sub that in for the D. And I'm solving for the R. Now, if you wanted, you could have started this answer by just reversing the fraction on the left and on the right. So taking the reciprocal on both sides. You can't just do one side, both sides. And then you would have the R on top. So it is a problem for us that the R is in the denominator. And we can get rid of that by cross multiplying. So I'm going to multiply 315 times pi, the top on one side with the bottom on the other, and then 180 times R. Now I can divide out the 180 to solve for R. Now when I convert to radians, I'm always going to keep it in lowest terms. I'm not going to make it a decimal unless it tells me that I can. So here it does not tell me that I can make this a decimal. I'm going to leave it with a pi, and I'm just looking at the numbers, and I'm going to reduce those to lowest terms. So what I notice is that I can divide both 315 and 180 by 45. So I'm dividing the top by 45, and I get 7 pi. And I'm taking the 180 and dividing that by 45, and I get 4. So 315 over 180 is the same as 7 over 4. And I'm done there. I'm in lowest terms. Again, I don't need units for radians. Moving on to the second example, I've got converting 1.6 to degrees. So again, no units here. This is in radians, the 1.6 radians. I'm going to set up my proportion. And then I'm just going to sub in 1.6 is a radian measure, so I'm subbing it in for the R. And then we're going to solve for the D. So here, I've got the D already in the numerator, so instead of dividing by 1.6 on the left, I'm going to multiply by 1.6 on the right. And here I'm converting to degrees, so it's fine to have decimals with degrees. So I am going to type this into my calculator. I'm going to have to round it. I'm going to round to 1 decimal place, or to the nearest tenth. So I'm just typing this into my calculator. 180 divided by, I'm using my pi button, and then times 1.6, and I get 91.7 degrees. So make sure you practice that on your calculator. Make sure you know how to use it. All right, moving on to our last section, how to draw radians. You're going to need to use this skill, just like we did in grade 11, you have to draw those rotational angles, and then we used SOHCAHTOA and the cast rule to find the ratio, or if they gave you the ratio, to find the angle. We're going to do the exact same thing tomorrow or in our next lesson with radians. So I need to know how to draw the picture. So when a question asks you about something about a pi by b radian, so maybe it's 7 pi by 4, or maybe it's 5 pi by 3, they're going to give me this radian angle. You're going to draw the unit circle sectioned into pi by b sections. So the denominator is what I'm looking at, right? The b here is the same as the b here, and it's going to tell me how many sections to draw on top, because I'm taking pi, remember pi is half the circle, or 180 degrees, and I'm going to cut it into b sections. So in my first question, I've got 3 pi by 2. So I'm just going to ignore the 3 for a second, because that's telling me how many sections to count out. And I'm just looking at the pi by 2. It's saying take the pi, the top half of the circle, and divide it into 2 sections. So I'm going to take, we always start, just like in grade 11, we start on the positive x-axis, and then I'm going to go around. I'm thinking about, well, this is pi, and I want to cut it into 2 sections. So that's nice and easy. Here's going to be, oh, I should use my straight line tool. Here's going to be the first one, and then here's going to be the second one. So notice I've taken the pi, I've divided it into 2 sections. I'll do the exact same thing in the bottom of the circle. And then to figure out where 3 pi by 2 is, I just have to count around until I get to the third one. So I start with 0, right? I haven't moved at all. And I get to 1 pi by 2, 2 pi by 2, and there's 3 pi by 2. So I'm going to rotate I'm going to rotate, again, starting at the positive x-axis until I get to the third bar that I drew. And this will be the angle 3. This will be the angle 3 pi by 2. Again, this terminal arm would be pi by 2. This would be 2 pi by 2. which is the same as pi, right? If you reduce that to lowest terms. And this one here would be 3 pi by 2. And then, of course, here we would be getting around to 4 pi by 2, which is the same as 2 pi. Okay, for our next example, 5 pi by 3, we're going to do the same thing. We're going to try and cut the circle. And when I'm thinking about cutting, I'm looking at the denominator, and I'm just going to cut 1 pi, so the top half of the circle, into 3 sections. So again, I start here at my positive x-axis, and I'm going to cut this top half of the circle into 3 sections. So I'm going to do there, there, and there. I've got 1, 2, 3 wedges or pie slices on the top, and then I'll repeat the exact same thing on the bottom of the circle. And then I can count around the circle. So I'm counting this time by pi by 3s. How many pi by 3s do I have? So I start at this at the positive x-axis. The first arm is going to be 1 pi by 3. Then the second arm is going to be 2 pi by 3s. Then the third arm will be 3 pi by 3s. But we know that 3 over 3, that's just 1, so this is the same as pi. Then the next one will be 4 pi by 3s. And then the last one will be 5 pi by 3s. And so that's the one that we were looking for, so I can draw my angle. And there it is, that's my 5 pi by 3. We'll repeat doing the same thing now in the last example. The last example is asking us to draw 7 pi by 8. I'm just going to thin out my line a bit. So what this tells me to do is take the pi, the top half of the circle, and cut it into 8 wedges or 8 sections. So I'm just going to start here with my positive x-axis, and there's my ending line at pi. I want to cut it into 8 sections, so that's a nice even number. So I'm going to cut in half, and then I'll cut in half again, half again. So now I've got 4 sections. This would work if I had a pi by 4 here in my question. But I need pi by 8, so I got to cut all of these again in half. It's a lot of sections for pi by 8. So 8 sections on the top, but I need another 8 sections on the bottom. Slide that up. So again, just taking, and I keep cutting in half each of my wedges until I have 8 on the bottom as well. So the denominator only tells me half of the sections in the whole circle. Sorry, technical difficulties. Okay, so what I've got here is 8 sections on the top, 8 sections on the bottom, and that gives me 16 sections in the whole circle. So the whole circle will be double the denominator. And now to figure out my angle, I'm just going to count around the circle. And again, I can label each one of these lines. I start at the positive x-axis. The first one I'm counting around by pi by 8, so the first one will be 1 pi by 8. Then the second one will be 2 pi by 8s. 2 pi by 8s, I can reduce that to lowest terms, and that's pi by 4. All those people that love fractions are going to love this, right? So 1 pi by 8, 2 pi by 8s, this one's going to be 3 pi by 8s. Then I'm going to end up with 4 pi by 8s, but again, I can reduce 4 8s. That's the same as 1/2, so pi by 2. Notice that we already had that here, right? Pi by 2. So we know that that should come out the same in lowest terms when I get to that positive y-axis. Then I've got 5 pi by 8s. Then 6 pi by 8s, again, 6 pi by 8s, that reduces, that's the same as 3 pi by 4. Then I've got 7 pi by 8s. And remember, when I get to this negative x-axis, this should always reduce to pi, because I know that that's like 180 degrees, and we know that's the same as pi. So here I've got 8 pi by 8s, but again, that does reduce to pi. And then you can keep going around the circle and labeling these. It's not necessary in every question to label every arm, but sometimes it will be helpful for you. Every time I have an even numerator, I have to reduce. It should work out that when you get back around to the positive x-axis, you're going to have double. The numerator will be double the denominator with a pi tagging along. And so that gives me 2 pi. I can also think about it as 0 radians as well. So now, actually, to find my angle, 7 pi by 8, again, starting at the positive x-axis, I'm just counting around until I get to the 7th line. And there it is there. Since my fraction is a not an improper fraction. I know that I'm going to end up in the top half of the circle. Notice that here 5 pi by 3 I ended up with an improper fraction, and so I end up in the bottom half of the circle. All right, so you can find the homework for today on the homework log. Good luck and have fun.